Welcome students in the series of PYQ 2023-24 objective question of the chapter Nuclei. This topic is very important for the CBSE NEET as well as for IIT JEE examination. So let's begin with the first question which we have. The density of the nucleus in which mass of each nucleons is 1.67 10 to the power minus 27 kg and R naught is equals to 1.4 10 to the power minus 15 meter is. We have an options 1.453 10 to the power 17 kg per meter cube, 1.453 10 to the power 16 kg per meter cube, 1.453 10 to the power 19 kg per meter cube, and 1.353 10 to the power 17 kg per meter cube. Now let's move with the solution part. That U is given 1.67 10 to the power minus 27 kg. R naught is given 1.4 10 to the power minus 28 meter. R naught is the radius of the nucleus. D we have to calculate. The value of D is equals to 3U by 4 pi R naught cube. So just put all these value here, students. Like the value of a U, which is a unit mass of this system, is a 1.67 10 to the power minus 27. By the value of a pi is 3.14, R naught cube is given 1.4 10 to the power minus 16 cube. After solution, we get the result 1.453 10 to the power 17 kg per meter cube, which is option 1. The ratio of radii 197, AU 79 and 107, AG 92. Options given 0.765, 2.325, 1.226, 1.785. Solution which we have A1 is equals to given 197, A2 107. So R1 by R2 is a question mark. So R1 by R2 is A1 by A2 to the power 1 by 3. 197 by 107 to the power 1 by 3. That means 1.84 10 to the power 1 power 3. After a solution, we get the value of 1.226. According to this, the correct option is second. Correct option is the third one. Next question, we have the radius of the nucleus of the atom with A is equals to 216 of R naught is equals to 1.2 fermimeter is 1.2 fermimeter, 2.4 fermimeter, 3.6 fermimeter and 7.2 fermimeter. Let's move with the solution part, students. R naught is equals to 1.2 fermimeter. A is equals to 216. R is equals to, so R is equals to R naught A to the power 1 by 3. Putting all these value, 1.2 fermimeter. A is equals to 216 to the power 1 by 3. After solution, we get the value 7.2 fermimeter. According to this, the correct option is option 4. Next question, we have distance of a closest approach when 5 mega electron alpha particle approaches a gold nucleus is Z is equals to 79. That comes 45.4 fermimeter, 23 fermimeter, 30 fermimeter, 55.4 fermimeter. Solution which we have, E is equals to 5 mega electron. Mega electron, that means 1.6 10 to the power minus 13 joule. Now Z is equals to 79 is given, E is equals to 1.6 10 to the power minus 19. Put all these value here and get the value of E, which is 2ZE square. 2ZE square by 4 pi epsilon naught D. We just put all these value here and after a little bit calculation, we get our main result. Which is a 45.5 fermimeter. According to this, the correct option is option 1. Next question, we have a heavy nucleus at the rest breaks into the fragments which flies off with the velocity is 8:1. The ratio of radii of fragment is 1:2, 1:4, 4:1, or 2:1. So let's move with the solution part. Given that V1 by V2 is equals to 8:1. So R1 by R2 is equals to V2 by V1 to the power 1 by 3. That means 1 by 8 to the power 1 by 3, which gives the value of 1 by 2. According to that, the correct option is 1:2. Next question, we have a matchbox of 5 centimeter into 5 centimeter into 1 centimeter. Dimensions is filled with matter. Nuclear matter's weight is in the order of 10 gram, 10 to the power 8 gram, 10 to the power 12 gram, and 10 to the power 15 gram. So we have an options these. Let's move with the solution part, students. D is given 10 to the power 14 gram per centimeter cube. V is equals to given 5 into 5 into 1, which is 25 centimeter cube. G is equals to given 980 centimeter per second square, and W is equals to, we know that mg's will be there. Mass is equals to density into volume. So density is given 10 to the power 40, and the value of V volume 25. The value of G 980 centimeter per second square. Student, keep in mind the value of actually G is 9.8, but in centimeter per second square this will be 980. So after a solution we get the weight of this in order 10 to the power 15 gram. According to this, the correct option is option 4th. Next question, we have the mass number of helium is 4 and that of sulfur is 32. Radius of a sulfur nuclei is larger than that of a helium nucleus. Helium nuclei by. So here we have an option 4, 2, 6, 8. Let's move with the solution part. A1 is equals to 4, A2 is equals to 32 is given. So R1 by R2, it comes A2 by A1 to the power 1 by 3. We just put this value 32 by 4 to the power 1 by 3. This gives 2 to the power 3 to the power 1 by 3, which gives 2. So the ratio is actually comes to, according to that, the correct option is option 2nd. Next question, we have in the sun about 4 billion kg of matter is converted into energy each second. The power output of the sun is in watt is 3.6 10 to the power minus 26 plus 26 watt, 0.36 10 to the power 26 watt, 36 10 to the power 26 watt, 0.026 10 to the power 26 watt. Let's move with the solution part. M is equals to given 4 billion kg. That means 4 10 to the power 9 kg. T 1 second. P is equals to W by T. That means MC square by 1. So the value of M given, C given, and the value of P given. We just put this all value and get the result in the terms of power. That means watt. So that comes 3.6 10 to the power 26 watt. This is the right answer for this question. If you have any questions, students, you can ask. You may ask in the chat session. Next question, we have the binding energy per nucleon U238 is about 7.5 megaelectron volt, whereas it about 8.45 megaelectron volt for the nuclear having masses half of the uranium of 238 split into two exact half of the energy released to be 6.4 megaelectron volt, 119 megaelectron volt to 38 megaelectron volt, 476 megaelectron volt. Now let's move with the solution part. So that total energy are equivalent is equals to binding energy of the product minus binding energy of the reactants is given. That means binding energy is given for 8.5 into 238 minus 7.5 into 238. That gives 238 times 8.5 minus 7.5, which gives the value 238 megaelectron. According to that, the correct option is the 3. Next question, we have the masses of a neutron, proton and neutrons are 1875 mega electron volt per c square, 938.21 mega electron volt per c square, and 939.50 mega electron volt per c square respectively. The minimum energy required to separate the neutron and proton in the deuterium nucleus is 1875.49 mega electron volt, 2.22 mega electron volt, 1.11 mega electron volt, and 12.22 mega electron volt. Now the solution, the mass effect is a 939.50 mega electron volt per c square plus 938.21 mega electron volt per c square minus 1875.49 mega electron volt per c square, which is equals to 2.22 mega electron volt per c square, and we know that energy equivalent or required energy will be delta m c square. For that scenario, that 2.22 mega electron volt per c square into c square comes 2.22 mega electron volt. According to that, the correct option is the option 2. I hope students this simple question you are understanding. There is no kind of typical questions are there. The next question we have, the masses of a 2He4 nucleus is 0.03 AMU, atomic mass unit, less than the sum of the masses of a 2 proton and 2 neutron. The binding energy per nucleon is 2He4 is about 7 mega electron volt, 28 mega electron volt, 4 mega electron volt, 2 mega electron volt. Students, let's see the solution of this question. So A is equals to given 4, that means atomic mass is a given 4. Delta M, that is change in the difference, is a mass defect, we are saying 0.03 AMU. So binding energy per nucleon is a delta M C square. So C square in the mega electron volt is a 931.5 by mass of atomic mass, we are saying mass, nucleon's mass. So 0.03 931.5 by 4, which comes 27.9 by 4 gives a value 7 mega electron volt, which is option A. Next question we have a 1 kg of iron, which is specific heat 120 calorie per kg per Kelvin per centigrade, is heated by 1000 degrees centigrade. The increase in its mass is 0, 5.6 10 to the power minus 8 kg, 5.6 10 to the power minus 16 kg, and a 5.6 10 to the power minus 12 kg. Solution which we have is equals to 120 calorie per kg per degree centigrade. Put this value of and converted this into joule. So Q is equals to ms delta T. M is a 1 kg is given here. After substituting all these value here, we get the value of a Q 12 into 4.2 10 to the power 4. Just put all these value together and get the result 5.6 10 to the power minus 12 kg. According to the option, which is the option 4th is the correct one. I hope you understand, students. Next question we have, the binding energy per nucleon for deuteron and alpha particle are x1 and x2 respectively. The energy released in the reaction 1H2 plus 1H2 gives out 2He4 will be x2 minus x1, 2 times x2 minus x1, 4 times x2 minus x1, and 8 times x2 minus x1. Solution which we have are relative is equals to binding energy product minus binding energy reactance. That gives the value 4 times x2 minus 2 times x1 plus 2 times x1. It gives 4 times x2 minus x1, which gives the value of a third. So according to this, the correct option is a 3. 14th question is, in nuclear fission, 0.1% mass is converted into energy. The energy released in the fission of 1 kg mass is, we have an options 2.5 10 to the power 5 kilowatt hour, 2.5 10 to the power 7 kilowatt hour, and 2.5 10 to the power 9 kilowatt hour. The fourth one 2.5 10 to the power minus 7 kilowatt hour. Let's move with the solution part. So for 100 kg this will be 0.1 kg. And for 1 gram is equals to 0.1 10 to the power minus 2 or 10 to the power minus 3 kg. So we can say that Like E is equals to delta mc square, delta m 10 to the power minus 3, and with that 9 10 to the power 16, so this gives 9 10 to the power 13 2, and 9 10 to the power 13 divided by 36 10 to the power 5 gives the value of a 2.5 10 to the power 7 kilowatt hour. I hope you understand, students. So the correct option for this question is second. Next question we have the kinetic energy of alpha particle emitted in the decay Pu 94 to 38, U 92 to 34 plus He to He4, we can say in atomic mass unit of uranium 238, uranium 234 and alpha particles are 238.04955 U, 234.04095 U and 4.002603 unit respectively. Neglect any recoil of the nucleus. First, 4.392 mega electron volt. Second, 6.259 mega electron volt. Third, 5.592 mega electron volt. Fourth, 4.952 mega electron volt. So let's move with the solution part. Pu 94 to 38 gives the value of 92 uranium 234 plus 2He4. So the mass of plutonium is 238.04955. This is a given mass. Mass is a given for the particle uranium 234 for 234.04955 and the mass of the helium is 4.00260 unit. So for a mass of the react minus mass of the product, this gives the value 238.043553 and delta M resultant will be received 0.006. What we did, students, we just simply minus the main value, that is the M product, to the original, that is the reactance value. So that gives 0.006 and this value I'll just put in the delta MC square. So delta M C square 931.4 931.5 mega electron volt. The answer which we receive, that is a 5.589 mega electron volt, which is the option 3. I hope you understand. Next question which we have. The energy released in the following reaction 1H2 plus 1H3 gives out 2He4 plus 0N1. Mass of a 0N1 is a 1.00876667 AMU. Mass of 1H2 is a 2.01410 AMU. Mass of 1H3 is a 3.0160 AMU. And mass of a 2He4 gives 4.0026 AMU. Their options are, we have these. So let's move with the solution part. 2He2 plus 1H3 gives out the value of 2He4 plus 0N1. So Mn is equals to 1.00867 unit. Mn is equals to 1.00867 unit and mass of the 1H2 gives out 2.01410 unit. Mass of the 1H3 is given 3.0160 unit and mass of the product is a mass of the helium plus mass of the neutron, which gives the value 5.01127. Students, what we are doing actually, we are taking the both side masses. So mass of the 1H2 we are taking, mass of the 1H3 we are taking. That gives the total amount of mass. Okay. So mass of this, if we are adding together to get, we are getting actually some values, which must be like little bit a kind of a difference with this masses. So if we are taking the difference of these two masses, we are getting the value of a delta M actually. And because of finding the energy, we need the value of a delta M. What is the delta M? Here, delta M is the mass defect. So, like mass of the product of M times 1H2 plus M1 times MH3. This gives the value of 5.03010. Again, for finding the value of a delta M, which as I told you earlier, this gives the mass effect, and because of we need the value of energy, so we need the value of delta M also. This delta M value gives 0.01883 and the value of energy delta M times 931.5 mega electron volt, which gives the answer 17.53. According to this, we have the correct option, option number 2. Next question we have the energy required to split 8 or 16 nucleus for 4 alpha particles. The alpha particles is 4.002603 unit and that of oxygen is 15.994915 unit. That gives a first value, that is 11.6 mega electron volt, 13.7 mega electron volt, 14.4 mega electron volt, or 15.8 mega electron. Let's move to the solution, students. So this will give this equation like oxygen is split into the helium part plus some energy takes place. So mass of the oxygen 15.994915 unit. Mass of the 4 alpha particles is 4 times 4.002608,034. So the complete mass gives 16.0104. Datum which we calculated the difference of the two masses, which gives 0.01549. And the energy which we calculate by this putting value 14.4 mega electron volt, which is option 3. I hope you understand, students.